Hello everyone. In this particular video, we are going to solve the problem number 1.48 from Irodov, and that is related to kinematics. So let us first read out the problem and then we will solve the problem step by step. A solid body rotates with a deceleration about a stationary axis with an angular acceleration beta directly proportional to root of omega, where omega is the angular velocity. Okay, so let us say this is a solid body which is rotating about an axis which is passing through this particular point with the angular deceleration that is given as beta directly proportional to root of omega. Okay, if we remove this particular proportional and if we equate, then we can write beta is equal to k times root of omega. Let us say k is a positive quantity and it is constant. Now here, as it is decelerating, solid body is decelerating, so we can write this beta as minus of d omega by dt, that is equal to k into root of omega. Okay, now in the problem it is asking to find the mean angular velocity of the body averaged over the whole time of rotation if at the initial moment of time its angular velocity was equal to omega naught. Okay, so let us say at t is equal to 0, omega is given as omega naught, and it is asking to find the mean angular velocity till the body is stopping. Okay, so now what we can do, let us first find out the omega as a function of time. So we can write minus d of omega is equal to let us take this root of omega this side and dt to this particular side. So we can write minus d omega upon root of omega is equal to k into dt. Let us integrate both the sides, and we can write here minus of omega to the power minus half into d omega integration is equal to k into dt integral from t is equal to 0 to, let us say, t. At t is equal to 0, omega is given as omega naught, and at time instant of t, let us say omega is omega. Now here if we integrate, we can write omega to the power half whole divided by half from omega naught to omega is equal to k into t from t is equal to 0 to t. Here we can write minus 2 times omega to the power half minus omega naught to the power half, that is equal to k into t. So from here we can write omega to the power half is equal to omega naught to the power half minus kt by 2. So if we square both the sides, then we will get omega is equal to omega naught to the power half, or let us write it as root omega minus kt by 2 whole square. Okay, now we have to find out the time instant at which the angular velocity is 0. So that we can integrate, we can find out the mean angular velocity from t is equal to 0 and to the time instant where the omega is 0. So we will equate it to 0. So we will get root of omega naught is equal to kt by 2. So basically t is equal to 2 times root of omega naught by k. This is the time instant at which the body is stopping. Now let us find out the mean angular velocity. For that we can write omega mean is equal to omega into dt integral from t is equal to 0 to, let us say, this particular time instant, let us call it as capital T whole divided by dt integral of t is equal to 0 to capital T. Okay, and omega is given as root of omega naught minus kt by 2. So let us equate it here, root of omega naught minus kt by 2 whole square dt integral whole divided by t. So here we can square it first. We can write omega naught plus k square t square by 4 minus kt into root of omega naught into dt integral from t is equal to 0 to t whole divided by capital T. So we can integrate. Omega naught is constant and the integration of 1 is t. So we can write omega naught t plus k square t cube divided by 12 minus k into root of omega naught into t square by 2 from 0 to capital T whole divided by capital T. So we can write omega naught t plus k square t cube by 12 minus k times root of omega naught into capital T square by 2 whole divided by t. So 1 tt will get cancelled and we will get omega naught plus k square by 12 into t square minus k times root of omega naught by 2 times t. Now let us substitute the value of capital T from here, that is 2 into root of omega naught by k. So let us substitute here omega naught plus k square by 12 into 2 times root omega naught by k, 2 times root omega naught by k whole square minus k times root of omega naught by 2 into 2 times root of omega naught by k. So here k square will get cancelled and here k will get cancelled and we will get omega naught plus 4 by 12 into omega naught minus 2 will get cancelled omega naught. So omega naught will get cancelled and we will get omega naught by 3. So this is the value of mean angular velocity we got. I hope the entire procedure is clear. Thank you.